So today we are going to solve this problem. Check if the digits are equal in the string after operations 2. This is the Q3 of the today's contest, Leetcode contest 438, and it is a hard problem. And what this problem states that you are given a string S consisting of digits. Perform the following operations repeatedly until the string has exactly 2 digits. For each pair of consecutive digits in S, starting from the first digit, calculate a new digit as the sum of the first 2 digits modulo 10. Replace S with the sentences of newly calculated digits, maintaining the order. So the order here is important. So we need to maintain the order and in which they are computed. Return true if the final 2 digits in the S are same. Otherwise, return false. So okay, I got the sense of what we need to do in this problem. So let's try to do here. Let's take an example. So we have this string consisting of 4 digits 3902. What we are trying to do here is we are trying to sum the consecutive digits, and we are modding it with 10, and we get a single digit, and then we keep doing this process until we get to a string of length 2. So 3 plus 9 is 12, mod 10 is 2, then 9 plus 0 mod 10 is 9, and 0 plus 2 is 2, mod 10 is 2. Then we gonna go again, we will do the same operations. 2 plus 9 is 11, mod 10 is 1, and 9 plus 2 is again 11, mod 10 is 1. And now our string length became 2 and also same, so return true. So the next thing is, how do we figure it out? How do we get from this to this number, and we figure out if they are same or not? So there's a first thing, we can for do a brute force solution. The brute force solution will go and keep performing the operations until our length becomes 2, and we can simply calculate it and we can check. So that's an easy question, and that was the first question of this problem. But now we have tighter constraints. We have over 10 to the power 5. The string can be over 10 to the power 5, which makes it a O of n squared solution, which doesn't pass. So now you have carefully seen that it took over 2 iterations from reaching from the initial number to the final 2 digits. And how we got this is basically the length of the string minus 2. So length of the string is 4 minus 2, which means 2. So we need to take 2 iterations from this number to reach to this number. So now if you closely look, this just seems similar to a Pascal triangle. A Pascal triangle is a triangle that is made by consecutive digits, and Leetcode has a very similar problem related to that. I recommend you to solve this Pascal triangle 1 and 2 before coming to this problem. As you can see in the animation, so you can see this Pascal triangle is built by taking the sum of the above two elements and constantly building from gradually from top and bottom. Similarly, here we are also building the sum, but we are modding it to 10. And initially in the Pascal triangle, it starts with a 1, but here it starts with a random numbers. Okay, uh, let's just figure out some more things, some more patterns to help solidify the clarity for this problem. So now what I'm trying to do is, let's just remove the mod 10 part from the problem statement, and just some consecutive digits. and what will happen, we'll see. So the initial numbers are 3, 9, 0, and 2. Now now see if we want to sum it without modding, so it will be 3 plus 9 for the first digit, then 9 plus 0, and similarly 0 plus 2. So these are the sum for this consecutive digit, this consecutive digit, and this consecutive digit. Let me just provide some spacing so that it feels convenient to see. Now let's continue this further one more time so that we can reach this 11th. So here what we will do is, again we will add these two numbers. So 3 plus 9 plus 9 plus 0 and 9 plus 0 plus 0 plus 2. So now these are the final numbers. Now if you carefully observe the final numbers, that is the target for the problem. The sum is, let's just write the sum, 9, 9, 18, 19, 20, 21. So 21 and 11. And if you mod them with 10, you will get 1. And if you here also mod it with 10, you will get 1. So now can you spot a pattern here? So if you see that the last this number, how the number made from the initial numbers, is basically 3 contributes one time to the final number, 9 contributes twice, and 0 contributes once. Similarly here also 9 contributes once, 0 contributes twice, and 2 contributes once. And as you can see there, the pattern is, the order of these occurrences, the contributions are similar. So as you can see, 1 contribution, 2 contribution, 1 contribution, 1 contribution, 2 contribution, and 1 contribution in each number of that row. So, and how many iterations it took us? 2. So it's nothing, if you carefully observe, it's nothing but just binomial coefficients of all of the 2. So it's 2c0, 2c1, and 2c2. And what are these values are? So 2c0 is 1, 2c1 is 2, and 2c2 is always 1. So what is this 2c0 is basically, it's binomial. If you learned higher school mathematics, you probably know about binomial coefficients. So binomial coefficients are nothing but it just tells us the amount of ways a subset of numbers can contribute to the final number. So we found out by the help of binomial that how much each number is contributing. So once we find out this thing, we can simply find out the sum of the final two digits easily from with the help of the initial digits, and then we can like mod it, and if we check if it is 1 and if they are both same, then we can return true, otherwise we can return false. And this is very efficient. So the Pascal triangle is also uses the same properties. A Pascal triangle is no different. It's also uses binomial coefficients. So if you see that here, it's 0, 1, 2. To 2c0, 2c1, 2c2. Here it's 3c0, 3c1, 3c2, 3c3. You can like learn about it. There's one video on YouTube. I will link to that. It's from a guy Striver. His channel is on YouTube, so you can learn about it. I also learned from that channel also, so you can like refer to that. I will put a link onto it. So whenever you see something like this kind of a pattern where the below pattern is building upon the consecutive integers, it's basically nothing. It's Pascal triangle, and Pascal triangle always builds from binomial coefficients. So you just need to find out the binomial coefficients, and we are done. So let's look at the code. Since I've already solved it, I will just simply explain it to you. So what we are trying to do is we first calculate the size of the string, then we calculate the number of iterations. So number of iterations is n minus 2. Basically the iterations are this, from reaching from the initial to the final step, how many iterations we need. Then we maintain two variables for tracking the sum of the last, sum of the last two digits, because in the end we need the sum of these two digits, and we mod it with 10. And if they are same, we will return true, or otherwise we will return false. So now what we are trying to do is I'll go through each iterations and calculating the binomial coefficient by modding it with 10 also. So how I am calculating the binomial coefficients modding with 10 is I'm using Lucas theorem. Lucas theorem states that you can split a binomial coefficient uh, into two parts or multiple parts, given that they both should be co-prime, and and in the end I am reconstructing the binomial coefficient with the using of Chinese remainder theorem. So these two topics I will cover in a separate videos, because if I cover it now it will become long. So it's we are just nothing we are doing, we are just efficiently calculating the binomial coefficients, uh, basically that NCK, and I'm modding is at 10. Hope you enjoyed and hope you learned something new. I definitely recommend solving some prior problems related to Pascal triangle and learn about binomial coefficients, and then you solve this problem. Then it will be very beneficial and helpful for you, because it will lay up your foundation, will stronger, will build your foundation strong, so that you can like solve similar problems easily in the future. Thank you and bye bye.